In problem number 3, we have an 8-gram bullet that is shot into a 4 kilogram block. Rests on a frictionless horizontal surface. The bullet remains lodged in the block, and the block moves into an ideal mass spring and compresses it by 8.7 centimeters. Then, the spring constant of the spring is 2,400 newtons per meter. They're asking us the initial velocity of the bullet is closest to. So first thing we're gonna do is going to realize that the initial momentum is gonna be the same as the final momentum. And we can represent this as mv initial being equal to little m plus m capital times b final. Now we add these two because once the bullet gets to the block, they're both attached and they're one. Before it collided, we had the bullet separated from the block. But now they're together, so we have to combine them. As we solve for b final, we get little m divided by little m plus capital M multiplied by initial velocity. Moreover, we can rewrite the initial velocity as little m plus capital M divided by little m multiplied by the final velocity. So as we said at first, the initial momentum being equal to the final momentum, we can set 1/2 times little m plus big M multiplied by v squared, final v squared, equal to 1/2 kx squared. Now this whole thing is going to represent the total mechanical energy before the collision. The right side is going to represent the final mechanical energy after the collision, where the maximum compression occurs, and where there's no kinetic energy. So, in this equation we can cancel out the 1/2s on both sides, and we end up with v squared final being equal to kx squared divided by little m plus capital M. Or we could say that final velocity is equal to square root of kx divided by little m plus capital M. Sorry, it was kx squared. So square cancel, and it's going to be square root of k over little m plus capital M multiplied by x. So we also know that delta x is going to be equal to 8.7 times 10 to the negative 2 meters. So now we're going to use the equation initial velocity equal little m plus big M divided by little m multiplied by final velocity. And we found out that the velocity, or final velocity, is going to be square root of k divided by little m plus m, and that outside we multiply by x. So as we put in the values for little m, capital M, k, and x, we end up with this whole thing right here. So we're gonna divide, we're gonna cancel out, we're gonna end up with an initial velocity of 1,066.57, which in this case is closest to letter C, 1,100 meters per second. And that's the final answer. The initial velocity of the bullet is closest to 1,100 meters per second.